All right, in case you missed it in class, I'm going to go through and work through this worksheet. And maybe if you need to hear it a second time, you can watch this video, and I hope it helps you out. So I'm going to go through just like I did in class, and I'll stop and pause it and do some work and then progress ahead. So it says, use the following information about the masses of elements in each pair of compounds to help you suggest formulas that account for these ratios. So we're going to be looking at different compounds, compound A and compound B. And you can see here, compound A has 57.1 grams of oxygen. Compound B has 42.9%, or not percent, grams of carbon. So the first thing I want to do is, it says determine the value of the ratio of the mass of oxygen per mass of carbon in each sample. So all I have to do is divide 57.1 by 42.9, and that will equal 1.33. For the next one, compound B, we have 72.7 grams of oxygen and 27.3 grams of carbon. When you divide that, that's going to give you 2.66. So I can fill those in down here also. So the B says, how does the mass ratio for compound B compare to that in compound A? Well, 1.33 and 2.66 are related in that compound B is twice or 2 times larger than A. Explain these ratios as improper fractions. It may have been a while since you've done improper fractions, so I'm just going to kind of walk through this step by step and kind of go through the logic of it. The first one I'm going to look at is compound A. Compound A, the ratio was 1.33. What that means is that by weight, we have 1.33 grams of oxygen to every 1 gram of carbon. So this is 1.33 grams of oxygen for every 1 gram of carbon. Now, 1.33 is the same as and 1 and 33rds over 100 is the same as Now I'm going to turn this into an improper fraction. So in order to do an improper fraction, you're going to take the 3 and you're going to multiply it by whatever whole number you have. And then you're going to add that product to your numerator. So what this means is I've got 3 times 1, which is 3, plus 1, which is 4. So this becomes 4/3 as an improper fraction. Let's look at B. B was 2.66 grams of oxygen to 1 gram of carbon, which is the same as 2 and 66 over 100, which is the same as 2 and 2/3. So my improper fraction is going to be 3 times 2, which is 6, plus 2, which is 8. So this is going to be 8/3. So this is going to be my improper fraction for A, and this is my improper fraction for B. Now there are 2 different hypotheses we can look at here. We've got hypothesis 1, which is where if our idea is that atoms of carbon and oxygen have the same mass. Hypothesis 2 is atoms of oxygen are heavier than carbon by the ratio in compound A. So we're going to be thinking with hypothesis 2 that oxygen is a third heavier than carbon. So let's take a look at hypothesis 1 first. Our improper fraction was 4 to 3. What that meant was we had 4 oxygen to 3 carbon. So our formula would be C3O4. Now I'm going to draw those molecules. I'm going to use red for oxygen and blue for carbon. So there's my 3, trying to make them touching, 3 carbon, and here's my 4 oxygen. Whoop, I think I'll put 2 above and 2 below, why not? Okay, so there's my compound for C3O4. Now I'm ready for hypothesis A, or sorry, hypothesis 2. Hypothesis 2 relates to how does the mass ratio for compound B compared to that in compound A. Well, we said B is 2 times larger than A. So the very simplest combination that I could write would be C, whoop, make my pen a lot smaller, would be CO. That's the very simplest combination I could do. And for this idea that oxygen is heavier than carbon, I'm going to make 1 carbon atom, and then I'm going to make an oxygen atom that's larger, about a third larger. So there's my compound for hypothesis 2. Let's go ahead and look at hypothesis 1 for compound B. My improper fraction was 8 thirds, which meant I had 8 oxygen to 3 carbon. So my formula would be C3O8. So to draw this molecule, I'm going to draw my carbon first. And then I'm going to have 8 oxygen. So something like that. For hypothesis 2, where I'm supposing that atoms of oxygen are heavier, so again, I'm going to say that I'm going to do the simplest possible compound. I know I have 1 carbon, so there's my carbon. For oxygen, I know I have twice as much oxygen in compound B than I do compound A. Whoop. I'm going to make my oxygen bigger because this is the one where we're supposing that it's bigger. And that would be what my compound would look like. My formula would be C CO2. So for question 2, we're going to go through the same, and I'll pause this so I can do the math because I don't have this one memorized. All right, so same thing. I'm going to first find out, I'm going to determine the value of the ratio of mass for copper to oxygen. If you're working through this with me for the first time, go ahead and you fill in what is the ratio for each compound, A and B, and then also do how does the mass ratio compare for compound B to compare to that to compound A. So when you do the math, you find that the ratio for A is 3.98 and the ratio for B is 7.93. When you look at those two ratios, they are B is 2 times larger than A. You'll find in chemistry, we're going to be doing a lot of rounding to numbers that make sense. So we'll do that right now with these improper fractions. So for A, we had 3.98, and again that's going to be 3.98 grams of copper to 1 gram of oxygen. This is going to be the same as 3.98 over 100, which is very close to 1. This is where we're going to kind of round up to numbers that are going to make a little more sense for chemistry. So 3.98, 98 being, or 98 over 100 being close to 1, we're going to say is 1 over 1. So now I follow my formula for making an improper fraction. 1 times 3 is 3, plus 1 is 4. So this will give me an improper fraction of 4 over 1. For B, we had 7.93 grams of copper per 1 gram of oxygen. Again, I'm going to put this into a mixed fraction. Rounding wise, this is close enough to be able to say that this is a 1-to-1 ratio. With these, really, you're going to be looking at rounding using that 9, the 9. So this would be 7.1 or 7 in 1 over 1. Turning this into the improper fraction, 1 times 7 is 7, plus 1 is 8. So this is going to give you 8 over 1. So this is for compound A, and this is for compound B. So again, we're going to look at hypothesis 1, which is the same as the first question, where we had atoms of copper and oxygen have the same mass, and hypothesis 2, where copper atoms are heavier than oxygen atoms by the ratio in the compound A. So let's go ahead and fill these in. So my improper fraction for A was 4 to 1. For B, it was 8 to 1. Remember, the 4 went with copper, and the 1 was for oxygen. So my formula for this one is going to be Cu4O. My formula for B is going to be Cu8O. So let's go ahead and draw these in. I'm going to use red for oxygen, and I'm going to use green for copper. So there's for hypothesis 1 for compound A. And I'm going to go ahead and do compound B. So there's my compound B, Cu8O. For compound A, again, I'm going to go for the smallest ratio I could have, and that would be just Cu and O. For compound B, I know I have 2 times more copper than I do oxygen, so that would be Cu2O. And now I'm just going to draw these. My oxygen. And there's my oxygen for compound B. Now, with this hypothesis, I'm supposing that copper weighs more than oxygen, so I'm going to use a larger size. For this one here, it would look something like that. The next question says, which hypothesis seems more reasonable to you? Justify your answer. Well, there's quite a few different reasons why hypothesis 2 makes more sense. Hypothesis 2 is most correct because it is not reasonable to suppose that all atoms have the same mass. If you look at the periodic table, we've got all the different atomic weights. Atoms have different weights, so it's not reasonable that these compounds would have these numbers in hypothesis 1, because we know that atoms don't all have the same weight. So that's the most reasonable answer. All right, so for this last part here, this is where everybody worked on this in small groups. I'll go ahead and give you the answers for these and explain, especially when we get down into question 4. So pause the video now and go ahead and complete question 3. You shouldn't have any problems for those. All right, now you can see and double check your answers. So the simplest formula you should have gotten for A is ClCu, 1 chlorine to 1 copper. And for B, we know that we've got 2 times more chlorine than we do copper, so Cl2Cu. All right, go ahead and fill in for question A, question 4A, get the answer for the mass ratio. All right, so now that I've got the mass ratios for chlorine to iron, it says in B, the ratio you determined in step A gives the mass of chlorine that combines with 1 gram of iron in each compound. To determine how the mass of chlorine in compound B compares to the mass of chlorine in compound A for the same amount of iron, divide these ratios and express the answer as an improper fraction. What does this fraction tell you about the number of chlorine atoms in each of the 2 compounds? So the first thing I have to do is divide one ratio into the other. When you divide that, you get 1.5. 1.5, when you turn it into an improper fraction, is going to be 3 over 2, which means in compound B, you're going to have 3 atoms of chlorine. This was compound A, so in compound A, you're going to have 2 atoms of chlorine. So that's what that fraction is going to tell you about the number of chlorine atoms in each of the 2 compounds. What would be the formula of the 2 compounds, assuming that each contains 1 atom of iron? So this is going to be Ca will be Cl2Fe, and B is going to be Cl3 to 1, oops, that's a Fe. I'm going to back all that up. I wrote a 2 instead of an E. Cl2Fe, and for B, it's going to be Cl3Fe. And there's your answers.